Welcome to today's webcast series presentation, Managing Stormwater Through Low Impact Development and Green Infrastructure. My name is Beth Brooks, Director of Civil and Structural Engineer Media. Thank you for joining this webcast, which is sponsored by Presto Geosystems. Before we begin today's presentation, first some general information about the webcast and the GoToWebcast platform. The views of the speakers and organizations participating in this webcast are their own and do not necessarily reflect those of Civil and Structural Engineer or its publisher, Zweig Group. If you have any technical difficulties while viewing this webcast, please submit questions or a brief explanation of your technical problem using the Question tab on GoToWebinar Control Panel, and a representative will assist you. During the webcast, you can also submit questions to our speaker using the same Question tab. Submit your questions at any time, and we will try to answer as many as we can later in this webcast. Zweig Group encourages group learning for our events. If you are viewing the live webcast with a group on one registered person's computer, that person must complete and submit the multiple viewer registration form for the group in order for everyone to earn credit. Download the multiple viewer registration form from the Handouts tab on the control panel. Submission instructions are on the form. Today's presenter is Sam Justice. Sam is the civil engineer responsible for overseeing project evaluations, managing the engineering activities of Geosystems' worldwide partners, and coordinating research and development. She has experience specializing in water resources, stormwater management, and rock soil stabilization. Sam holds a geotechnical engineering degree from the University of Michigan and a geological engineering graduate degree from Michigan Technological University, and is a registered professional engineer. She provides technical and project-specific support to consultants, contractors, and distributors for all of the Geosystems products and application areas. And now I'm going to hand it over to Sam.
Thank you, Beth. Welcome, everyone. I hope you're all having a good day so far. We're going to dive right in. So I'm going to take the screen over. Hopefully you can all see this shortly. The focus of this presentation is on the way to help manage stormwater runoff from developed areas with low impact but highly effective landscape elements. The ideas presented will follow the accepted practices for green infrastructure and low impact development design. First of all, the question is, what is green infrastructure? And what does it mean in terms of residential and commercial construction projects? The Environmental Protection Agency, the EPA, describes green infrastructure this way. Essentially, people harnessing nature and using it as an infrastructural system. And why would we do this? To protect and restore the natural water cycle, manage urban stormwater from developed areas, and create a way for excess stormwater to infiltrate to the source. The point of green infrastructure is to figure out construction and building techniques that work with the water cycle and help keep stormwater under control. Then the question becomes, what is low impact development and how is it different or similar to green infrastructure? Much like green infrastructure, low impact development is described as an approach to land development or redevelopment that works with nature to manage stormwater as close to its source as possible. And systems and practices that use or mimic natural processes to infiltrate stormwater, essentially keeping the water controlled or contained at the source rather than contributing to runoff. Low impact development also emphasizes conservation and using on-site features to protect water quality. So green infrastructure and low impact development have similar goals. related to land planning and design that include ways to reduce runoff and promote the natural water infiltration from ever increasingly built environments in a way that's as natural as possible. Common examples of planned green infrastructure or low impact development systems are rain gardens that are built to absorb runoff from pavements or parking lots, bioswales, also known as vegetated swales, and other green medians to allow immediate water infiltration along roadways. Things like green roofs to control temperature and water of new or renovated buildings, and porous pavements for immediate infiltration in parking areas, access roads, or along walkways. Reducing a site's overall environmental impact can help reach green infrastructure, low impact development, or green building goals for buildings in protected or densely populated areas. It can also help you meet stormwater regulations that limit the amount of hard, impervious surfaces you might have in your community. The amount of impervious surface allowed on a project site is often a concern along shorelines, in areas with high water tables, and in new build residential areas. So it should be considered for every project, not just those specific scenarios. With green infrastructure and low impact development practices, there are numerous benefits for vegetated systems. Generally, any vegetated solution benefits by creating highly aesthetic, natural green spaces in your community, with park-like settings with a double intention to also promote infiltration of stormwater. Additionally, vegetated surfaces are much cooler compared to asphalt or concrete pavements, reducing the heat island effect that is inherent with so much hard surfaces in cities. Stormwater benefits can be significant as well. The size and need for conveyance and treatment of the infrastructure can be reduced, minimizing the development footprint and offering cost savings. Water quality is improved and groundwater is recharged through natural infiltration. Flooding potential is mitigated by vegetated permeable areas that allow water infiltration at the source. So, with that bit of background about green infrastructure and low impact development, Beth, will you introduce polling question number 1? So hopefully you guys are all seeing this in your polling tab. And the question is going to be, low impact development and green infrastructure practices should only be used in the following applications. A, when water quality is a concern. B, when building a new large office building. C, when space is limited on my site. Or D, all of the above. So when do you want to follow these practices? What's a good application for these? Looks like we've got a good response here. Solid, everybody saying all of the above. And that's correct. Like we just covered, you really want to be able to focus on doing these type of good practices for all of your projects. It's required in some locations, but it's always a good practice. Okay, so we'll move back on. Our first thing that we're going to focus on today is porous pavements. And we're going to cover the options, their benefits, and how they can be integrated into low impact development design. So first, a little bit of background. The regulatory market has been driving the need for porous pavements for the last 10 to 15 years. Things like high stormwater management value, which is the desire to make the best use of valuable high-cost land and reduce the need for stormwater ponds or stormwater infrastructure by increasing the porosity of pavement. And 40 years after the Clean Water Act, it continues to create the need for stormwater management for both quality and quantity. And most states have developed non-point pollution regulations with specific targets that you would need to meet. Local regulations may even require more stringent standards if the project is near a protected wetland or water source. Porous pavements are one exceptional way to meet these criteria while still performing in a structurally meaningful and long-lasting way. So there are a few different options for porous pavements that you can consider. Probably the most well-known are hard surface porous pavements, which are pervious concrete, pervious asphalt, and permeable paver blocks. These are hard surface porous pavements that act very similarly to their non-porous counterparts, so regular concrete or asphalt, but they can often suffer from durability challenges, which can limit the overall effectiveness of the system. So some of these significant drawbacks include cost, which is one of the biggest factors, both during installation because of the requirement for specialized materials, contractors, and then also higher maintenance expenses over the lifetime of the project. Regular deep cleaning to address clogging is required, as is resurfacing or replacement due to raveling, where the material starts to fall apart, because it occurs due to the weak bonds within the material. In general, pervious concrete and asphalt surfaces tend to look unfinished, leading to some questionable aesthetics. Paver blocks, while attractive, have much more limited open spaces for those infiltrations, so you're not actually permeating quite as much, and they tend to be quite expensive. The other type of porous pavement options that are out there are molded from a high-density polyethylene, HDPE plastic. These molded paver units can be either rigid or flexible, and they're usually designed specifically for either a vegetated or an aggregate stone surface. Grass pavers are designed for occasional use or infrequent traffic. Pavers with non-bound aggregate, meaning that there's no glue or tack holding those stones together, are designed for a regular traffic with no frequency restrictions. Much like other pavement designs, the structural strength and loading capabilities will depend on the native subgrade strength, the infill material you choose, and what base materials are used. The greatest benefit of a vegetated rigid paver is that the pavement is a green surface that's created. Local vegetation is used to create a seamless look with existing plants. A topsoil and a clean aggregate blend are used as a base layer, allowing root growth while providing the necessary structural strength. Aggregate rigid pavers are designed for that higher frequency traffic, including daily use. The low-cost, non-engineered stone can store water in the surface layer and the base underneath. The large pore openings virtually eliminate drainage issues. Local colored stone allows the use of locally sourced materials, as well as creating a nice delineation between areas. Another option is to use a 3D Geocell confinement system, and that can be used for either grass or stone pavements. Compared to the rigid pavers, Geocell systems are flexible with larger cells, which is great for creating a more natural looking area, but will typically have a deeper overall cross section. For grass pavements, that same topsoil stone mix, typically called an engineered fill, is required to give it structural strength. Aggregate pavements, a clean crushed stone, or even a low quality stone can be used. Specific project conditions will dictate whether a flexible or a rigid system is required for your project. And that's something we here at Presto Geosystems are open to discussing on a one-on-one basis. So if you have any questions, feel free to type them either in the chat window or contact me once this presentation is over. So the main limitation for grass pavers is the traffic frequency. Occasional use is recommended. So think 1 to 2 times a week or less. Common applications include fire or utility lanes, access roads, special event or overflow parking at things like churches, sporting events, parks, things that you're not going to drive on every single day. Shoulders and road medians are perfect applications for a stabilized grass pavement. Allows for a natural looking vegetation while creating a structurally stable area suitable for traffic to pull over in the case of emergencies. Applications for aggregate pavements are similar to grass, but they have no frequency restrictions. Feel free to drive on them all day long. Uses such as fire and utility lanes, access roads, parking, road shoulders, pull-off areas, walking trails, and sidewalks are all common. With aggregate infill, porous pavements can handle both wheeled and tracked equipment and can be designed for incredibly heavy loading, including construction equipment and container storage. In this example, a Geocell pavement stabilizes that open graded aggregate. An asphalt pavement at this trucking yard was plagued with poor drainage issues, severe rutting due to the heavy loads, and soft base soils, and just had such costly maintenance, the owners were looking for a new solution. The pavement was replaced with a Geocell system for optimal permeability and has been in service for nearly 20 years. So there are quite extensive benefits to using porous pavements in green infrastructure and low impact development land planning. The first is going to be aesthetics. With grass pavers, local vegetation is used and they look just like the lawn around them. So they're quite camouflaged. You don't see that there's something there. Aggregate pavers are meant to be visible and were designed, in this case, with a nice herringbone pattern, similar to that paver stone aesthetic that we talked about earlier. The infill stone color can be varied like it is here to create a sense of separation, which is useful if you have walkways, parking lots, and road shoulders. Grass and aggregate porous pavements infiltrate stormwater at its source immediately once it starts raining. So there's minimal runoff from the surface, reducing your flooding potential. These pavements are beneficial in the filtering of contaminants and reducing non-point source pollution before it enters the groundwater system. Because aggregate pavers have a high percentage of open area and utilize that open graded stone, stormwater infiltrates exceptionally fast, and it's captured and retained on site. The pavement performs as an on-site stormwater detention basin, storing water in the pavement layer and in the base layer, so it can then naturally percolate into the groundwater and recharge that system. Pavement designs may include a portion for porous pavements, as illustrated in this graphic, where the porous zone is integrated with an impervious pavement to collect that hard pavement runoff. This is a great way to expand parking areas if more space is needed. Both the rigid and flexible porous pavement systems can be incorporated right up against an impervious surface, so there's not going to be an area of potential failure where they meet. Pavements that allow water to flow through the surface into a base of stone can reduce the requirements for stormwater storage at the surface. Reducing the pond size, or maybe even eliminating the pond completely, will save on land space, and it's safer in the long run. Plus, underground storage means no home for mosquitoes, and I, for one, am all for avoiding insect breeding areas. So grass and aggregate systems both have a much cooler surface than even porous concrete, asphalt, or paver blocks. This helps to reduce the heat island effect in cities, which affects communities by increasing the energy demand, the use and cost of air conditioning, and overall air pollution. Plus, it's just more comfortable when it's not that hot. Using these systems can contribute to earning green building credits for your new projects. The rigid cell wall pavers are made from 100% recycled HDPE plastic. This recycled material is from objects like milk jugs and helps keep those materials out of landfills where they might otherwise end up. The grass and aggregate pavers align well with the impervious pavements to collect their overflow and direct for storm drains. The paver units are easily field cut to handle curves, existing structures, and other obstacles on site. Most aggregate pavers have a very high crush strength, over 5,000 psi when filled, because of their rigid and shared wall connections. This strength allows for less base to support the loads, so you're going to have a significantly thinner cross section. If you use the flexible system, you're going to need a deeper cross section. Not to say one of those is better than the other, but your project conditions may dictate how much excavation space you really have. The interconnected pavements have exceptional load distribution and are highly resistant to movement, torsional loading stresses, and concentrated rutting. Loads are dispersed across the pavement. They have pavers with disjointed cell walls tend to be flexible, so they don't have that same load spreading capability. So it's something to keep in mind. If you know that you're going to have very high real load stresses, it might dictate what type of porous pavement you're going to have to use. The infill placement is very fast, as both tracked or rubber-tired construction vehicles can drive on these rigid pavers when they're unfilled. Specialized paving crews or equipment are not necessary. They're typically installed by a landscape contractor, so you're saving on time and labor costs. Confined aggregate or topsoil systems require little to no maintenance. Once you place it, you can forget it. And we do have these delineators available so that you can make parking lines, drive lanes, that sort of thing. There are options to customize these porous pavements to your specific project. And I've mentioned cost a couple times. Both rigid and the Geocell 3D confinement systems offer all of the benefits that hard surface porous pavements do, but at a much lower price point. You can see the rigid pavers are 25 to 40% lower, and the Geocell system is extremely economical. So we're going to do a quick case study. This is a gravel parking lot at the Citadel in South Carolina. It had some typical problems that can be solved using a porous pavement system. Close proximity to a saltwater marsh and strict stormwater regulations limiting runoff and pollutants into this critical tidal area were major concerns for the renovation for this parking lot. The client wanted a low maintenance, low environmental impact solution to replace a failing asphalt parking lot that had become compacted over time and developed potholes and cracking and just generally looked unnice. There wasn't space or time to construct a conventional stormwater detention pond above ground, so they needed somewhere to put that water. Rigid pavers were utilized as a low-impact solution. Installation is fairly straightforward. The paver units were installed over a non-woven geotextile and connected to form a continuous interconnected area. In this case, no additional base was installed. The open graded aggregate was then installed and raked into the paver cells. Because of the strength of those paver cell walls, equipment can drive right on them, like you see here. And it's pretty easy to use a standard hand rake to make sure all the cells are filled. The open graded stone is highly permeable. It allows water to collect in the aggregate voids and then drain naturally without running off. Additional base could have been designed if more storage was required. The porous parking lot stalls were also designed to collect runoff from adjacent hard surface pavement drive lanes. And this is our finished pavement. In all, 20,000 square feet of parking were installed for over 100 vehicles. So that was a lot of information about porous pavements. So let's have a quick question before moving on. Beth, please introduce polling question number 2. So the question is, true or false? It is not possible to create a porous parking lot that can handle everyday use. So can you do it? True or false? Actually backwards, you're right. Can you do it? False or true? And looks like we're getting a lot of false answers, and that is correct. You can create a lot that can be used every single day, all day long. You're going to want to use the stone infill for that. If you have the vegetation, you want to try and limit that use. So the question was a little bit backwards, but it looks like most of you got it right, that yes, you can create a lot used for every day. Okay, moving on. Another way to reduce runoff and integrate green infrastructure into your building designs is with swales and vegetated stormwater channels. Grassed swales help collect parking lot overflow, slowing and infiltrating the water and directing it into storm drains. Swales and drainage ditches are typically installed for low to moderate intermediate flows. So it's not going to be a river. It's not something that's going to see water every day, and it's not intended usually to handle flash flooding sort of situations. Testing was performed with the GeoWeb Geocell technology at Colorado State University to show how geocells function in channel and embankment applications. Vegetated channels can be designed for higher flows when stabilized with geocell technology and a TRM, a turf reinforcement mat, which is then laid over the GeoWeb. It's called an overlayment. The improvement is incredibly high, up to 30 feet per second, compared to 5 or 6 feet per second when using an erosion control blanket alone. This allows for lower impact vegetated channels to be used instead of expensive, high maintenance riprap, concrete, or articulated concrete blocks. So the important thing is to remember that the geocell needs that turf reinforcement mat over the geocell in order to reach these kind of speeds. So here's an example of erosion on an unprotected roadside ditch, and with the repair of the Geocell plus TRM solution. Notice the before erosion from sheet flow runoff. With the Geocell and TRM system, the water flows over the system without damaging the road or creating more erosion runoff. So it's going to have much lower maintenance. Oops, wrong way. Vegetated channels can also be designed with tiered retaining wall structures on one or both sides. These are intended for low to moderate or intermediate higher flows during storm events. These channels can be designed with a very narrow horizontal footprint to accommodate more volume to help mitigate flooding potential. This is a great solution if you don't have a lot of space to build a channel. Typically, if you're along a roadside and you're in the easement area, this is a great solution to not be extending your channel onto private property. So we'll do a quick case study for a vegetated channel project. For this project in Cocoa, Florida, chronic drainage issues along the roadway were alleviated by incorporating Geocell naturally vegetated channels. When new channels were planned, the project goals included designing natural green channels that were able to resist erosion on the side slopes that had previously limited stormwater volume and contributed to flooding in the area. Overall, mitigation of the drainage-related flooding was a large factor in choosing the Geocell technology for the new design. So how did they do it? A tiered geocell channel with green fascia panels were built with geogrid reinforcement every few layers, very similar to how a mechanically stabilized earth block wall would be constructed. The soil was then excavated from the channel and was then put into the geocell openings. So you were saving on material costs by reusing the material that you had excavated. The steep banks offered two benefits: smaller horizontal footprint and deeper water storage. This is beneficial in areas where shallow side slopes won't fit, or you know that you're going to have the potential for very high water flows during storm events. And here you can see the channel shortly after installation, but before the vegetation was established. The relatively light weight of the wall system allows it to tolerate reasonable differential settlement without a loss of integrity. So the system performs well in soft soil environments. Concrete or grout infill can be designed when the outer walls are heavier, when heavier flows are expected, for greater resistance to the higher flows or shear stresses. And this is the channel today, about 4 years after installation. You can see how the natural vegetation is a welcome sight along the roadways. All in all, about 15,000 square feet of geocell wall panels were installed over a 6-month period. So, last polling question is going to be about stormwater channels. Beth, please introduce polling question number 3. Okay, this is another multiple choice one. When can a vegetated swale be designed to resist flows up to 30 feet per second? With a turf reinforcement mat only? With the GeoWeb 3D cellular confinement system only? With the Geocell and a turf reinforcement mat under the Geocell? Or the Geocell and turf reinforcement mat where the mat is over the top of the Geocell? So, what do we think? Looks like we've got pretty good options here. Everybody seems to be gravitating towards option D, using the Geocell technology with the turf reinforcement mat overlayment. And that is correct. You do want that TRM to be over the Geocells. And both of these in combination can provide great erosion control benefits, up to 30 feet per second water flows, which is usually more than enough for any typical urban stormwater channel environment. Great. So we're down to one last topic that we're going to cover today, and it's going to focus on green walls and how they can contribute to low environmental impact goals. Geocell technology can be adapted to create retaining walls, such as this vegetated levee. And this is how the stacked vegetated channels that we just saw are designed, by using this retaining wall type of system. The primary benefit of geocell walls is to create a stable, natural living structure with vegetation for aesthetic appeal. The open front cells allow rainwater to infiltrate, and the wall structure can absorb some runoff from the top of the wall, such as parking lots. So if you have a parking lot on top, water can run off and be infiltrated into the wall system without causing potential erosion to the area below the wall. Geocell walls are generally vegetated, but they can also be permeable when filled with an aggregate fill. They're designed either as a gravity or a reinforced wall, in the same way that mechanically stabilized earth structures, MSE walls, are built. An advantage that they have over MSE block walls is flexibility in poor soil conditions. Their lightweight allows them to handle differential settlement very well. So if you know you have a very soft soil environment, you can use the Geocell technology to help bridge some of those soft soils. Another advantage over traditional walls, such as a gabion basket wall, is the relatively shallow depth of the wall and the ability to create very steep wall faces, as steep as 80 degrees. We do have a case study for green walls. This is going to be a project in the Moreland Hills of Ohio, so southern rural Ohio. I was faced with having to retain soils in a very problematic soft soil area. But the piling system that they were initially quoted was very expensive, and they had wanted to maintain the natural environment. Concrete or modular block walls were considered, but ultimately they chose a vegetated geocell wall for its natural aesthetics and its lower cost. Here you can see the wall structure is constructed with a slight setback to allow the topsoil infill and vegetation to be planted. The backfill soil is a good drainable aggregate mix, and the wall can then be seeded either by mixing the seeds into the soil before installation or by spray seeding or hydro seeding once the installation is complete. And as mentioned, the system's inherent ability to withstand differential settlement in soft soil environments was extremely important at this site. The wall had varying heights along its length, which was also easily accommodated by the Geocell system. By using a Geocell wall, they didn't have to bring in invasive equipment such as augers or H-piles, and they were able to speed up the installation process. And here's the completely vegetated wall. The horizontal terraces allow rainwater collection, helping to minimize the runoff and potential erosion. Pretty much any type of grass or flowering vegetation will survive in these walls. So use a local vegetation and your upkeep will be pretty low. The engineering team here at Presto, including myself, work very closely with landscape designers and building engineers. And we do offer a free project evaluation service for each of the porous pavement, channel, or wall projects you may have. We'll analyze your site-specific data and offer a recommendation that will meet your project needs. And so we've made it. You can see that there are many ways to reduce stormwater runoff and minimize the environmental impacts from the built environment. Either using a rigid porous paver or the flexible Geocell technology will help you achieve your green infrastructure and low impact development goals. So thank you so much for participating in this system. We really look forward to working with you on any future projects you may have. My contact info is here. I'll leave it on the screen, but I'm now going to go for some questions. I don't see any, oh, hold on, there are a couple here in the question tab. So I will read those out and then get an answer to you. So our first one is how to maintain and clean your porous pavement. So there's a difference between if you have the vegetated system, you're going to maintain it just like it's a natural lawn. So you're going to put fertilizer on it if your grass needs it. You'll mow it with a standard lawnmower. You don't need any special equipment for that. If you have the aggregate system, either in the rigid or the flexible cells, it's still relatively low maintenance. You don't need to do any vacuuming to handle the clogging issues. Really, all you're going to want to do is make sure you don't let organics decompose on top. So fallen leaves, any trash that might get put on there. Standard lawnmower can, or a leaf blower can blow those off. As long as you get them off before they start decomposing and rotting, you're not going to block your system in any way. So very low maintenance. If you are in a snow environment, if you're somewhere that it's very cold and you get a lot of snow, you can plow them just like you would a regular lot. We just say you would need a plow boot on. It's a pretty standard thing that most plow companies have. So you don't really need any special restrictions there either. So very low maintenance, very easy to take care of. We do have maintenance guides on our website, which is on the screen at prestogeo.com. We have maintenance guides that can show you what exactly you would need to do. Next question just says vegetated pavements may fail even with occasional traffic. Not really a question, but we do say occasional does mean 1 to 2 times a week. And by fail, it really just means that the grass could die. The system itself will not fail. You'll still be able to drive on it. But if you drive on it much more frequently than we recommend, you do have the potential to kill that grass. Same as you would on a regular lawn. You drive on grass, you have the potential to kill it. So next question is, in areas where aggregates are difficult to obtain, can a fine aggregate be used for porous pavement? It's a difficult question because we do understand that aggregates are not readily available in every location, but part of the way the system works is by using relatively large aggregate stone so that you have those spaces between the stone where the water can infiltrate. If you were to put something like a sand in those, either the rigid or the flexible systems, the sand just is not going to infiltrate as fast. We generally recommend the stone not be any smaller than 3/4 of an inch, or about 20 millimeters. So if you're having trouble finding stone of that size, it may not be the best option just because otherwise you're going to get those clogging issues that we're trying to avoid. But if you have specific questions, if you have a specific gradation of a material that you have access to and you'd like us to take a look, feel free to email me and we can give you one-on-one advice so that you can get the best product for your site. How are porous pavers load-bearing capability evaluated, and does tensile strength play a role? So the load-bearing capabilities are evaluated in 2 different ways for the rigid versus flexible system. For the flexible system, yes, the tensile strength of the system does come into play. For the rigid systems, the tensile strength isn't as big of a factor in what exactly makes them stronger. We do have research available for both the rigid and flexible systems if you're curious about how exactly they can handle the loads that we say they do. And for both systems, they can handle up to AASHTO H20 loading, and that's going to be your fully loaded ladder truck from a fire station. So anything that's highway rated, you can drive on these systems. We do have research showing that they can handle those loads. So if you're curious about that, feel free to reach out to me directly. Next question is ADA accessibility an issue with the rigid porous pavement system? It can be in a vegetated lawn or vegetated system, same as it would be on a lawn. If you happened to put a particularly high heel right down in the middle of that soil, you're going to lose the heel. But in general, the cells of those rigid systems are small enough that you can go over them very easily with a wheelchair or a mobility walker, anything like that. The aggregate system is 100% ADA accessible. So we've used it frequently in walkways and in other areas of pedestrian use, and it has been rated ADA accessible. So you should consider them to be a part of that design. Next question, isn't it more difficult to walk on confined aggregate pavements? It's going to be similar to walking on a gravel road. You know, it's not going to be the perfectly smooth surface that say an asphalt road would provide, but it's not difficult in any way to walk on them. Like I said, wheelchairs, crutches, heels, anything like that are going to have no real issue walking on this system. So you really shouldn't consider that something that would be difficult for your end users to accomplish. Next question was about snow on the GeoGrid gravel systems. We didn't mention GeoGrids. I'm going to assume you meant Geocell. And so like I mentioned very briefly in the maintenance question, but I'll go over it in a little more detail. Snow removal is possible. You can put road salts or de-icers, chemical de-icers, anything you want like that down. Chemicals and salts aren't going to degrade the either the rigid or the flexible systems. They are made with the HDPE, which is chemically inert, so it's not going to have any sort of degradation or adverse reaction to a chemical or to salt placement. So that can be a great way to help reduce or remove any snow you might have. If you're looking to plow, you can with a regular plow blade. You really just should put the rubber plow boot on the bottom of the blade, and then you can run right over the top of the aggregate system and push that snow away. If you don't have a plow blade, or if you've got the plow that has the teeth or the tines on the bent end, you really just want to lift that up a little bit so you don't accidentally catch the product with the plow. So it just depends on what your maintenance equipment is and how exactly you standardly remove snow, but whatever you do for a standard road can be applicable to a porous pavement. So next question. So for the GeoPave systems, will the non-woven geotextile underlay become silted up or impermeable over time? So the type of geotextile that you put underneath the GeoPave system should be the one most applicable to your site. You can either have woven or non-woven, and it does depend what your native soil is. If you've got a very clay or silty, fine soil underneath the GeoPave system, you would want a woven geotextile so that it doesn't get clogged up. But in any of the cases, if you're talking about the possibility of it getting silted up due to fines running down from the surface, that's not an issue that we've seen in the 25 years that we've been installing these type of products. Generally, there's not enough silt really being pushed through that we see silting it up. And if there is concern, we recommend you move to a woven geotextile, and that would eliminate that problem. So it's something that we're happy to discuss, but in our experience, it's not been an issue. So next question is going to be, what types of vegetation are recommended for channel bank protection? Or do you plant on the steep banks? Do you let natural vegetation grow? So we recommend using local vegetation that, you know, if you're out in California, maybe don't put Kentucky bluegrass in because possibly it won't grow. But the vegetation is really up to you. There's not really any restrictions in it. You just want something that's going to look nice with the surrounding environment. So that's why using your local grass seed is going to create that seamless look. You can either go in and vegetate it with grown plants by hand, but that seems quite difficult, or you can just seed it and let it grow naturally. If you choose not to seed it, it will eventually be taken over by natural vegetation, but there's the concern that a lot of that vegetation would actually be weeds. So question of aesthetics there is what exactly you're looking for, but whatever local vegetation you have, seed it once installation is done, give it a couple months to let that vegetation grow, and it's going to look quite natural. So the next question is, where we are, bank erosion is only part of our issue. We must protect the flora and fauna as well. Can your system be sensitively installed so that it can achieve such mandated environmental sensitivity? Yes, it can. Like I've mentioned, you don't need specialized equipment to come in and do this. A landscaping crew can do it. And in fact, you don't need any equipment at all if you're in a very sensitive environment. A single, either rigid or flexible panel can be picked up by 1 or 2 people and spread out by 1 or 2 people. If you're in a particularly sensitive environment where you don't want to bring even something like a front end loader in, you can rake in the material, either vegetation or stone, by hand. You don't need to do any excessive excavating, so you're not going to need to over excavate the area and potentially kill any vegetation that would be near your project site. And because it's a much simpler installation, you don't need to build in access roads or any additional construction areas. You can have a very limited impact during your construction activities. And once they're installed, they're going to act just like a natural lawn. So it's not going to have any impact on the vegetation or the animals at that point. But yes, this can be a very, very low impact installation and can be put in areas such as wetlands or other protected environments. So the next question is, we've seen levees failing due to storm events. Can the design be modified to prevent such failures? It does depend on what type of failures you're seeing. There's multiple different ways a levee can fail. But yes, these products can be designed in such a way that they would be robust enough to handle heavy storm events where we've seen previous levees failing. In the case of the GeoWeb technology, we actually were able to put in a couple levees in the Louisiana area after Hurricane Katrina. So where levees had failed in that case, they'd come to us and we were able to design much more robust systems that were then used to replace those failed levees. So if you have any specific questions due to types of failure, or if you have a project that you're looking to install a levee, feel free to reach out to me and I would be happy to start that discussion. But yes, in a general sense, we can build those type of structures. Next question. What is the maximum height of the gravity wall that can be built with a geocell? So if we remember back, there were two different types of walls that you could build. The first one was a gravity wall. The second was a reinforced wall. The gravity wall does not have any additional anchorage to it. It literally is just held in place, as it sounds like, by gravity. We limit those walls to about 10 feet in height. So if it's a 10-foot or shorter wall, you can build it as a gravity wall system. If you're going to have a wall that's taller than 10 feet, you do need that additional reinforcement, and it would move to a reinforced wall design. And there is no height limit for that reinforced wall. So 10 feet is kind of the cutoff between gravity and reinforced walls. So there's a question that says, are the rigid pavers interlocking? If so, how do they interlock? And do they have to be anchored around the edges? So yes, the pavers do interlock. They have built-in molded tabs that connect between the panels, and then they also have connection devices to make sure the panels are held together. So yes, they interlock. That's how you get the full stabilization strength over a parking lot or access road area. In terms of having to be anchored, we do recommend they have some sort of edge constraint. So if you were to put them right up against an existing concrete curb or existing concrete road, that would be an edge constraint. If they are free on either side, we do recommend using steel or plastic stakes or pins just to help hold them in place so that the whole area doesn't shift. You don't need a lot of them. They're an infrequent edge constraint, but you should have something to make sure that your porous pavement area is going to stay where you want it to be. Next question is going to be about cost. We do not specifically provide cost quantities because there are a lot of different considerations for exactly what your cost would be. But in general, if we compare a Geocell technology road to a traditional concrete or asphalt road that would use that would carry high load, so say AASHTO H20 loading, the Geocell road is typically going to be either at the same price or as much as about 25% cheaper. So it'd be very, very unusual to see the Geocell come in more expensive than a traditional road. And like I said, usually they do come in significantly cheaper than that. Specific pricing, we can handle on a one-on-one basis. So a bit of a flip to a previous question, is there a minimum height for the vegetated walls? The minimum height is 1 foot. And that's because if it's any shorter than 1 foot, there's not really a point in building it as a vegetated wall. You would really just protect it, similar to how the vegetated swales looked in some of those previous photos. So if it's less than a foot, we don't recommend a retaining wall, but we've built them as short as 1 foot before. So how do the Geo products tolerate freeze thaw action? So they do quite well with freeze thaw. The rigid pavers have that interlocking mechanism, but they also are given a little bit of breathing space so that they can adjust to thermal changes, both in freeze thaw and in very hot weather. So when they're baking under the Arizona sun, they're going to expand because of that as well. But they're given flexibility while still being an interlocked system to handle those changes and those movements due to thermal activity. So it's definitely something we've considered and we've built into the design, so it should not be a concern. Can you prescribe repairs when underground utilities must be exposed? Yes, you can. For both the rigid and the flexible systems, you can get back underneath them if you need to. You would essentially cut open the area that you would need to, so right over your pipeline, say. You would cut the Geo products to however long you need. You get in there, do your repair work just as you normally would. And then as you are finished with your product, your repairs, and you're coming to put the products back in, you'll make sure the fill is back up to grade, and then you'll put in a new section of that product. So if you were to cut out geocells to repair a pipeline, you would get a new panel of geocells and cut it down to your size and install that into the existing system. So you won't be able to reuse the pieces that you take out due to repair, but you can fit a new piece right back into that section that you have removed. So not too different than if you had to cut a section of road out. Is there a defined life expectancy for these systems? So as mentioned a couple times, the products are all made with high-density polyethylene. High-density polyethylene has a expected lifetime of about 1,000 years. We obviously have not quite reached that deadline yet, but we generally recommend and say that our products will last about 75 years, which is usually more than enough for any specific project. But we've been doing this for over 40 years, and we haven't seen a lifetime degradation failure yet. So really, lifetime expectancy should not be a concern when using these type of products. Next question. Should the soil to support the grass in a grass paving application be a particular depth below the top of the paving area? The depth of your soil is going to depend on how much loading you're putting on top of it. If you're just driving golf carts over it because you're making a new pathway in your golf course, that's going to be very different than if you were to try and put a heavy fire truck over it. So generally that depth is going to be anywhere from 0 to 6 inches, and that specific depth is going to be project specific, but it's not going to be, you're not requiring a foot worth of soil or anything like that. So if you have a specific question, we'd be happy to answer. Next question. If an area has GeoWeb in place that is repurposed, can the GeoWeb be reused or recycled? Like I said, if you cut out a section of the GeoWeb, you really shouldn't reuse it, but it can be recycled at any standard plastic recycling facility, and it would just go in and it would end up being repelletized. So not reused, but yes, recycle. How are geopavements best cleaned of accumulated trash and other waste? You can go in with a leaf blower and blow them off into a collection site. You can use a rake. You could use a vacuum. Whatever your standard trash collection measures are now are what you should use if you were to install a geo product. What are the average infiltration rates of the various systems? If you're using topsoil, your infiltration rate is going to be whatever your topsoil rate is. Typically, it's around 0.15. Aggregate is going to be a bit higher because you are leaving those open spaces that water can infiltrate down much faster. So it depends a little bit on the type of material you use, but they are relatively quick, especially compared to an impervious pavement. Let's see. Would you recommend a tidal swale, in this case near the Chesapeake Bay, but I was going to consider it in any shoreline area? Yes, we've done quite a bit of installation along shoreline areas, and we've had no problems with it. It's just a different application and a different bit of design that you need to do, but it's very applicable to those type of locations and is a great way to handle runoff, erosion, and pollution concerns in those type of sensitive areas. So yes. So the next one is, actually we've already answered that one. And do you have any projects in residential areas that have utilized GeoBlock and GeoPave, which are our vegetated and aggregate rigid systems? Yes, we have installed both products in all 50 states and many countries beyond the US. If you are looking for something that maybe you can go see, feel free to email me and we can see if there's any projects that are near you. But we do have case studies up on our website showing both products in residential and commercial areas. So there's no restrictions to doing that sort of thing. One last question that just came in, can you complete projects in Canada? Yes, we work extensively in Canada and all over the rest of the world. There's nowhere that we are unable to work. We do have a network of distributors that are going to be local to you. We have one in every state, and we also have one in every country as well, at least one in every country. So we're not, we are based in Wisconsin. That's where our headquarters is, but we work extensively all over the world, and we work very closely with companies in all states and all countries so that we can get you the right products for your application. So that is essentially all of the questions that have come in through the question tab, and it is a little bit after my 1 hour. So thank you everybody for all of your questions. If you have any others, feel free to email me them directly. And I think Beth has a little bit more to say, so I'll turn it back over to her.
Thank you, Sam. As we finish up, please download your certificate of completion now from the handouts section. After downloading the certificate, enter your name in it and print it and save a copy of the PDF. This is the way that you're going to acquire your AIA approved PDHs. So it's very imperative that you go right now to the handouts section. You'll see the multiple viewer forms as well as the certificate of completion, as well as 3 handouts that Sam has included into our presentation that you can go ahead and download and print off for future reference. Let's see. Additionally, this webcast has been recorded and will be archived on csengineermag.com/continuing-education. This should be up and ready for viewing and to take your quiz in the next 24 hours. Archive viewers must pass a quiz in order to download the certificate of completion. Let's see. Also, a PDF will be available with written answers to all of the questions submitted during today's webcast. They may not be as thorough as what Sam was able to just give you. However, we will hopefully be able to touch on each question. Please visit csengineermag.com/continuing-education to view this. I already said that. And I think that wraps it up. Again, thank you so much, Sam and Presto Geosystems and everyone who joined us today.